So in running through all the different possibilities of ways we can combine functions, we've had simple exponent functions, right? The power rule. We've done products, right? We've done quotients. What have we not done? Chains. And chains. We have not done composition functions. Woo! Exciting. We have not touched that in a derivative, have we?
No.
That's what the chain rule's for. So basically what we're looking at, you might have some function where you have two of them composed. How do you calculate a derivative when you have a function inside of another one? Because here they're all separate, right? But this is actually inside. Yeah. That's how you can describe it, sure. So, outside. Inside. Good idea. Right? That the chain rule is going to tell us how to calculate that derivative. Again, calculating derivatives. Let me show you a couple of things. You done writing yet? Almost. But make sure I do the right ones here. So, we have a function, cosine of x cubed, right? Can you identify the inside and the outside functions?
Sometimes the outside one. That means x to the third is the inside one.
Correct. Key, that's the first key. Okay. We work outside in. Okay, so we start with the outside. There's a pattern. Just like the product rule or the quotient rule, you gotta remember the pattern. Okay, so if we work outside in, we're gonna do the derivative of the outside. Then we're gonna actually copy the inside, see how these patterns are playing out to be very similar to the product rule. Okay, so then we'll copy inside. And then we will do the derivative of the inside. We'll work our way outside in. Well, there's nothing else to copy that's left. the outside up, it's not gonna come back. All right, so what is the derivative of the outside? Yep, negative sign, and then copy inside. Okay. And then times derivative of the inside. You got it. Work outside in.
And that's your answer?
That's it. You're done.
Oh, wow.
First one, we were actually running that.
Yep. So again, I think a lot of people get confused here, identifying in and out. Okay, so let's look at one more. Quick note on trig functions. This gets a lot of people. You can rewrite this. This gets a lot of people. This is how you need to consider it for the chain rule. So what's the outside function? The square. Right.
Wait, why do you need to write it like that?
It just helps you see the outside function. Okay, here it looks like it's inside, correct? But it actually is the outside. The square is the outside function.
So we have to make sure we change it.
This gets people, that's why I'm showing it to you. You don't have to write it like this, but it helps you see it the first time.
How would you then do it?
Okay, so, outside, inside, correct?
Yep.
So the outside is what rule? Power rule, yeah. It's just an exponent, right? So I'm gonna bring it down. Copy the inside. So I've got my power rule derivative and I'm copying the inside, right? And then what's next? Derivative of the inside, which is. So be careful with those trig functions, they're exponents because of the way they're written.
So whenever a trig function has an exponent, it's the outside?
Yes.
Okay.
Okay.
Is that
All right. One more. No, 3 more.
No.
Oh, stop it.
It just gets harder.
Again, I'm showing you lots of situations so that you kind of get the idea of the pattern, you see it with different situations, you can adapt your things. It is, because we will rewrite this as
Yeah.
an exponent, right? So we have our outside and our inside, right? Oh, inside. I'm like, where'd she get that from? I get it, yeah, totally. Okay, derivative. Outside is an exponent, it's a power rule, right? There's your power rule. Now copy the inside. Times derivative inside. You might have to rewrite this one. I always rewrite these. Negative exponents, I always rewrite them. They can get ugly. little easier to see that, right? Much easier to plug numbers in and calculate slope. So, rewrite. Are we good? All right, I have a couple more to show you.
Wait, so why did we keep we brought it down this way? Alright, so.
I didn't keep any negative.
No, I know, on the board. So we took it out, we brought it down.
Take it down.
Why did we?
Subtract 1.
Okay.
1/2 minus 1 is negative. Yeah. Let's say y equals e to the cosine t.
Okay.
It will have e to the cosine t in it.
What is that?
Where's the outside?
Is that 0, 0, 0?
No. Okay, that's some of the finer points of the chain rule. The outside function here is e.
Oh.
Inside is cosine t. You gotta consider when you calculate a power rule derivative, the outside is the exponent, right? So if we go here, power rule is the outside. Here, when you do a derivative of e, e has got to be the outside. Okay, so what's the derivative of anything e? And then copy the inside, right? So you'll always copy. And then the derivative of the inside is again, the reason I show you it because it's got its own little quirk. Let me show you one that's a little bit. Are you good there? Yeah, you're not. Unless you're asked to calculate the equation of the tangent line. You can combine rules. So this is going to be a chain rule, right? What is going to be the derivative of the inside, though? It's a quotient rule.
That
Is
is
that x
so
plus
much.
1?
Yes. So this is a product quotient rule, or a chain rule and a quotient rule. Kate is disgusted right now. I can see it in his face. He's like, ooh, we have to do that.
Well, I swear,
It's not me.
Come up with math, just to torture a human being.
That's x plus 1.
Yes.
Yes.
It's not H.
You don't do this, you don't do it.
Okay, again, follow your pattern. What's first? Derivative of tangent, which is? And copy the inside. Alright, so derivative outside, copy inside, times
Huh.
the derivative of the inside.
We just leave this as it is.
Wait,
Wait.
is it high D low or low D high?
Low D high. Okay, so we have derivative outside, copy inside, times derivative of the inside. It's a quotient rule. Low
Oh, man.
D high minus pi below over the square of what's below.
We just leave that.
We're just gonna leave it.
Thank you.
These we cannot simplify. We could simplify that to 1 over x plus 1 squared. Right? X plus 1 minus x is just 1. So if you wanted to, you could algebraic or simplify very easily.
Every time we don't want.
So, in summary, yes, here is the general.
So was that last one the answer?
Yes. Done.
Yeah.
Open the map. If you have a function, composition of functions, the derivative, what's the outside here? You're gonna have to think conceptually. Sometimes we throw these things at you.
Well, F is outside.
Outside is F, correct? And the inside is G of X. So we have derivative of outside, copy inside, times derivative inside. If you look in your book, that's how the chain rule is presented. Okay? Formal, general chain rule. Tomorrow I'm going to show you a couple more. We're going to do a lot of derivatives. We're actually, if you get cold easy, bring a jacket tomorrow because we're going outside. I get you out of the classroom and you can play.
Yes.
Yes.
I like
You're
warm.
going to sit in that seat all day?
Yes.
What's wrong with you?
I'd rather be in my bed.
We're going outside tomorrow.
Ow.
If you need to bring a jacket, bring a jacket.
I'm not bringing sick up that day.
What's wrong with that?
You get show like an hour after this class.
Is this for Friday?
John just gonna show you a check.
Sorry,
I'm going to leave you in
sick
suspense.
tomorrow.
Well, when you say 90, you go in front of sweet, that's what happens. Seriously? What?
Just keep them coming.
Walkie
Okay.
No,
Clear Friday.
kidding. Funny.
Says what's that called? And where's Peter gonna bring that?
That's, okay, hold on.
It's not due till Friday. If you get stuck,
Awesome.
skip it, bring questions. We're off to start tonight. He said keep going, so I put 3-point infinity up there.
I have one question.
I don't want to confuse you, so we're just.
Yeah, I'm really
Yeah, I was
confused.
gonna write that.
Were you really gonna make sure you went you guys? Like,
Thought that would.
I go say someone else.
All right.
Let me turn the video off.
Okay.
And I'll come help both of you.
No.
My handwriting is atrocious.
yeah.
Thank you.
I
try hard.
Last one can take for that.
Is that 2 and 6?
Yeah.